We're going to continue our discussion on particle motion today, but today we're going to be able to use our calculator. This is your calculator. There are many calculators that look like it, but this is your calculator. Now, when we use the calculator on the AP, we use the calculator. So if the AP says use the calculator, you use the calculator. It is your best friend. Don't ever let it leave you by your side. Now, we're still going to have to show all of our work, so we're still going to have to use calculus and show all the work that leads to our answer. And we typically want to round to 3 decimal places. So let's take a look. A particle is moving along the x-axis, so it's just moving back and forth along the x-axis. And the position is given by this x of t equals t over 1 plus t squared, where t is measured in seconds, and x is, of course, measured in meters. For part A, we're asked to find the velocity at time t, and then the velocity at time t equals 2. So, of course, they're asking for the first part to take the derivative. So, to get the velocity, we're going to take the derivative x prime of t, and this is going to be our quotient rule, low, d high, which is 1, minus high, times the derivative of the bottom, which is 2t, all over the bottom squared. Now, if I look into the future, I see part E. I'm going to have to find the acceleration, which means I'm going to have to take the derivative of my velocity. This is pretty messy to take the derivative of as is, so I will clean this up. And you can check me on this one, but we're going to get 1 minus t squared on top, and in the denominator we're just left with this 1 plus t squared squared. This is my velocity equation, and this is what we always use. Velocity is a very important equation for us. We're going to find out from velocity. I can find my velocity at t equals 2. One, I can just plug it in, right? So this is my velocity graph. So if I want to find the velocity at 2, I just plug it in. I can find my acceleration by looking at its derivative or its slope. So velocity is very important, and next unit we're going to talk about how we can use velocity to even find position, and that becomes very important for us. So the velocity is what we graph. So on your calculator, you always graph the velocity function, and I'm going to go ahead and do that real quickly here. So let me see here. I like to use the scratch pad. Control divide. The only reason to get these calculators is just that little fraction feature. 1 minus. I'm going to use x. Whoops, somebody put me on cap lock here. 1 minus x squared divided by quantity 1 plus x squared squared. Press enter. I don't really care what the graph looks like, although it looks kind of cool. It looks kind of like a bell curve, right? I don't really care what it looks like, but I'm going to use it to find my velocity at 2 now. So to get v of 2, what I'm going to do, because this is my velocity curve, I'm going to use the graph trace feature on my calculator. So I go to menu, trace, we've done this before, graph trace, press enter, and I just type in the number 2. Press enter, and we get negative 0.12. And that is going to be meters per second. And there's our velocity at 2. Now we're going to talk about how we can use the calculator for our sign test. Now we've seen this a couple of days now. We want to find when the particle is at rest, when is it moving right, and when is it moving left. Now for us, this is our sign charts, or the first derivative test. So of course we're going to need our critical numbers. Now notice there is no constraints here, but we have to remember t has to be greater than 0. So I'm going to change my domain on my calculator. So to go to menu, window, zoom, and I'm going to change my settings, and I'm going to let my x-min be 0. My x-max can be 10, that's fine. Looking at the graph, I don't need that much y, so I might go from negative 2 to positive 2 so I can just see it a little bit better. And there we have our graph. And now I'm going to get rid of my label here because it's just going to be in the way. So let's see here. Why aren't you highlighting that? I guess I'm going to keep the label. Alright, escape. There we go. Now I'll get rid of my label, highlight that, and just delete that out of the way. Now, if we kind of notice right here, we have an intercept right there, and that's what we're looking for. So our critical numbers, of course, are x prime of t, which is v of t, equals 0. So I'm going to go ahead and find that value right there. Menu. I'm looking for 0. So I go to Analyze Graph. Remember, my critical number, I'm going to use the 0 feature on my calculator. I'm going to Analyze Graph. I just press 0. Now it says lower bound, upper, so I just go to the left of where that is, press enter, and I just drag it over, and if you notice, we get x equals 1, or in this case, t equals 1. Now I could solve that with the calculator, without the calculator of course, but we're using it so we might as well. So when I do my sign charts, remember velocity starts at 0, v of t, how does that affect my position? My one critical number that we have. And hit escape, just get rid of all that. Now if you notice, remember this is my velocity curve, so anything above the axis, the slope is positive, velocity is positive. Anything below, velocity is negative. So between 0 and 1, since we're above, the velocity is positive. So we are going to the right here. After, we're underneath, so we're negative, so we're going to the left. So we can answer the questions now. We are at rest at t equals 1, and that is because the velocity there is 0. We are moving to the right at I guess I shouldn't say on 0 to 1, and that is because our velocity is greater than 0, and we are moving to the left on 1 to infinity, and that is because our velocity is less than 0. Just like your grades if you don't do your homework. Here we see a question that we should be familiar with. Total distance. Now remember, for total distance, we've been doing this for a couple of days now. You will need your critical numbers, which we only have the 1, t is 1, and the endpoints. This is our candidates test. T equals 0, t equals 4. So when we set up our candidates test, use your table, t, your endpoints 0 and 4, and put your critical numbers in the middle. And remember, we're using the position x of t, which is t over 1 plus t squared. So at 0, if I'm at 0, I just plug that in, I get 0. 1, I could do this without a calculator. This is 1 over 2, so 1/2. And if I plug the 4 in, I'm going to get 4 over, what's that, 17 on the bottom? And then I want to find those distances. Now you might recall yesterday, distances must be positive, always positive. Distance cannot be negative. So I'm going to find the distances between 0 and 1 second. It looks like we traveled 1/2 of a meter. And then I got to find the distance between 1/2 and 4/17. Well, I really don't know what that is. If I can get the distance, I'm going to subtract them. So if I go to my home screen, I'll take 1/2 minus 4 over 17. You might look 4 over 17. You might be asking, why didn't you do 4 over 17 minus 1/2? I just want to show you something. So I get 9 over 34. I know it's got to be positive, so I just get the 9 over 34. That's all I really want. If I had done it the other way, if I would have done 4 over 17 minus 1/2, can't get that division right today, I will get negative 9 over 34. I still get the same answer because remember, we just want the positive on those. Alright, so to get the total, I now add them up. That's going to be 1/2 plus 9 over 34. And I'm going to go ahead and you do that in the calculator. 1/2 plus 9 over 34, and we get 13 over 17 meters. Now if you have that as a decimal, it's like 0.7647 meters. Now extra questions they could ask you, this is for free. extra, they could ask you what is the absolute maximum distance that we are away from the point. So that would be at, what is that going to be? 1/2. Where's the absolute minimum point we can be at? And that's going to be 0, 0. So nothing really new for us, right? Now, let's talk displacement. Remember we talked about displacement. This is the change in distance. In other words, it's your final value minus your start value. So if for us it's going to be s of 4 minus s of 0. So that's going to be 4/17 minus 0. So we have 4/17 meters. Now, you can also get that from your total distance, from your sign chart. Remember, in total distance, the signs must be positive, but in displacement, it's directional. So this will be plus 1/2 because we're moving forward, and this will be minus 4/17. And we can get our answer that way as well. So, but just take your final minus your start. All right, now this one, where we're looking for acceleration, yeah, we have to find acceleration, but we never use it, okay? So we know velocity is 1 minus t squared over 1 plus t squared squared. So there's my velocity. We got that from way up here from part A. So when I'm looking for velocity, I'm going to take its derivative. When I take acceleration, we're going to take the derivative. So acceleration would be the derivative of velocity. So we're going to use quotient rule. It's going to be ugly, but we're never going to use it. Low, 1 plus t squared squared, d high, negative 2t, minus high, 1 minus t squared, d low, which is chain rule. Ugh. That's going to become 2 times 1 plus t squared to the first times 2t. There's our chain rule. So we got low, d high, minus high, d low, all over the bottom squared. 1 plus t squared to the fourth. All right, we found it. Are you happy? Ours it is. But we're not going to use it, because to get acceleration at 3, we're going to use the calculator. So let's grab our calculator. You might recall on our calculator, a of 3 is the derivative, v prime of 3. We graphed the derivative. Well, there's a nice feature on your calculator. So the derivative on a graph on the calculator, what you're going to do is you're going to go to menu, your favorite friend, menu. You're going to go to analyze graph. And then you're going to scroll down until you see something that looks like it could be a calculus thing. Dy dx. That finds a derivative. So press enter, and then you just type in your position, which we're looking for at 3. So I type in 3. I press enter, and it gives me 0.036, and there is your slope. 0.036. It is acceleration, so it's meters per second squared. Very nice feature on this calculator. All right, go to part 2. We'll take a look at some more examples. We'll finish this up, okay? See you then.